In Solidity, the storage layout for arrays is a bit different for fixed size array and dynamic arrays. First, let's review how fixed size arrays are stored. The following contract contains a fixed array of 10 uint256 elements, and we have initialized the array with 10 elements. Now, the way these elements are going to be stored in the storage are going to be in the following way. Since Solidity recognizes that there are going to be 10 elements of uint256, is going to simply start, let's say in the slot 0, is going to allocate the first element, and then in the slot 1 is going to allocate the next element, which is 2, and this will continue till the slot number 9, where we are expecting to have the value number 10. So we will continue, and then in the slot number 9 we will have the value 10. So notice that since this variable fixed array is in the first position of the contract, we are going to start storing the elements from the position 0 of the storage. So there is a way in Solidity to test this, and we are gonna first deploy the contract. The contract was deployed correctly, and now there is a way to do in Solidity to execute scripts, and we can inspect the storage of the contract. So we can do web3.it.getStorageAt, and here we need to pass two values. First, the address of the contract, and then the slot that we are interested. In this case, the slot 0. Okay, here we are not getting any value. Sometimes Remix fails a bit. So I have noticed that we could call fixed array just to get a value. And then we try to call again the getStorageAt. This is a Remix bug implementation, but yeah, as you can see now, we are getting the value 1, which is the hexadecimal value of 1. Okay, so let's say we want to see the slot 9, and we are getting this value in hexadecimal, and this is actually number 10. Okay, and now we can even review, let's say, the slot 8, and we are getting the value 9 in the slot 8, which should be here. Let's say a slot 8 is gonna have the value 9, and this in hexadecimal is 0x09. Now let's review the case for dynamic size arrays, and let's clean this part, and let's simply initialize an array called dynamic array, and let's put two values, 1 and 2. Okay, so we are initializing our dynamic array, so we need to remove this number 2, and then we simply say initially there are going to be two values in this dynamic array, 1 and 2. So since Solidity cannot really know how much this array is expected to grow, Solidity stores the values of the array in a position following the following logic. The slot, in this case, where this variable is declared is 0, because it is the first one. So what Solidity stores here is actually the len. In this case, there are two elements in the array, so we store the number 2. if let's say we should have done this, the value of the slot will be 3. And then it's going to store the values in, let's say, keka 256 of the slot. So from here, Solidity is gonna start. So from this storage location, actually this is going to return a number that obviously looks very long, like it could be something very long, but that's actually a number. So by calculating the hash of the slot where this element is declared, in this case 0, from this point, Solidity is going to start storing the values. And the following values, so here we start, let's say 1 is going to be stored in the keka 0, and then we simply say keka 0 plus 1. So we are increasing by 1, and then here we store, let's say 2. So here we will have 1, then 2, and for the following one it will be the same, but obviously plus 2. Okay, and then here we are gonna have the number 3. So let's test this exercise and let's deploy the contract. Okay, deploy the contract, and then let's do this. But now we change the address of the newly deployed contract, and let's review what value do we have in the slot 0. In this case, nothing. As I mentioned before, Remix has a small box, so we need to call first dynamic array. Okay, we get the first value, and let's try again, get a storage at. Okay, now we are getting the element 3. Okay, why? Because we had 3 elements in the storage array. Okay, now let's do something to make easier our exercise. Let's include a function called add element to dynamic array, and we simply pass a new element, and this is going to be external. And if you remember how we add elements to the dynamic array, we simply say push new element. Okay, let's try again. Okay, I'm going to first check what is in the slot 0. So let's fix the issue with the bug. Okay, we get 3, but now let's add an element. Let's add, let's say 4. Okay, it was successful, and now let's get again the value of the slot 0, and now it's 4. Why? Because we are increasing the elements of the array. Okay, now we need to calculate the hash of the storage slot. So to do so, let's include a property, and we are gonna call it bytes 32 public slot 0, and this is gonna be the keka of, we say ABI encode 0. Okay, so this slot 0 public variable is actually gonna give us, it's gonna do the calculation of this keka of the slot 0. So we could simply query that property and get the value, so we can start validating that really the values are stored there. Okay, let's start again. We deploy, and then let's call dynamic array, and then get the storage. Okay, 3. Let's add the element 4. We call again to see what is happening. Is 4 correct? And we can continue. And we are gonna see how now the value should be 5. Okay, but now let's get the value at slot 0. Okay, this is the hash of 0. So if I do get a storage at this value, we should be getting the number 1, and is correct. Can you see? Now, as I mentioned, we simply add 1. So instead of 3 plus 1 is 4, and you see the value 2, and now plus 1 and the value 3, and we can continue.